Okay, welcome back. That was some great R-generated art, Harvey. I love that. And just wanted to remind everybody, Ellis and Eric and Harvey and Phil, everybody's back behind scenes down yet. Everybody's behind scenes working on this. So just imagine lots of people scurrying around keeping this conference, even though you're just seeing my face. So I want to also, speaking of standards and the way that we can use standards in context, and then also the context of Admiral being nominated for our award, I want to introduce Sam Hume, who's going to give a talk, an invited talk on CDISC and initiatives, CDISC initiatives and collaborations. So Sam, take it away.
Thank you, and I appreciate the opportunity to talk about CDISC initiatives and collaborations. Fair to say that CDISC has a pretty broad portfolio of projects ongoing right now, so I'm not going to touch on all of them. I've kind of curated the list here to pick out one, things that are new that you might not be aware of, and two, things that I think that might resonate with this audience. Even with the kind of curated list of projects, there's an awful lot to chat about within these different projects. So what I'm going to do is just kind of give you a couple of the highlights, give you a feel for what we're working on. And I would say if you have an interest in digging deeper, certainly you could check out the CDISC website, or feel free to ping me and I will do my best to get your questions answered myself or connect you with somebody that can get you the details that you're interested in. Before I get into the specific initiatives, just want to take a minute and talk about the big picture, take a step back a little bit for some perspective. Within standards development these days, it's fair to say that we spend much more of our effort thinking about and working towards how software and standards can be used to implement the standards with data. So standards implementation is a big area of focus. And that means that the metadata that we use in standards, as well as some of the standards projects themselves, really focus on how do software tools work with the standards and how could we advance that and enable more automation. And so in my team then, in the data science team, we work on those with the standards development folks and also get involved with things like technical standards. So what you'll find is that in many of our projects, we have work where we're carving out standards like API specifications and data models with the idea that this really does help enable better interoperability. And so we have quite a number of projects where those are part of our deliverables. And if you're working on things like API specifications, software tooling is really a helpful part of the project to test out to make sure that, hey, is this API spec and is this data model really going to work as we intended it to? And then we've got other projects like the core initiative, our open rules project, which I'll talk about in a minute, which, again, if you're going to author a conformance rule in metadata, you really need the ability to test that out to see if it works before you publish it. So again, software tooling is a big part of what we do. So with this push towards standards that are more implementation friendly for software, technical standards, and associated software tooling, really targeting more automation. And at the same time, also pushing forward with this idea of openness. And a couple of examples. One, for the CDISC library, our repository for all our standards metadata. It's available to anyone. So if you're a member, non-member, anybody can get access. If you're a software developer, you can use the API and redistribute your code with the idea that anybody can get access to the library and it doesn't cost anything to do that. I think the other example is just our commitment to open source and developing open source packages, which I think as we go through some of these projects today, you'll see some examples of that. So I think as we think about standards implementation and using software to take advantage of the new metadata that's available, it's important to know the CDISC library really provides the foundation for this. And we have an API that's used then for tools to reach in and retrieve the standards metadata. And of course, we have all our foundational standards are there, all versions of all the standards, the control terminology. But it's also important to know there's a lot of new metadata that's been added, and we're in the process of adding even more. So if we think about look at the pipeline listed there below the dotted line there, we see quite a few different types of metadata, starting at the top with conformance rules. So now we have these executable conformance rules that we're creating that are in the library, available via the API. and lots of new stuff like biomedical concepts, dataset specializations, code list subsets, implementation guide text. And these are brand new. These are things we've really published. So there's a model, they're in the library, available via the API, and the contents there pretty much for review at this point, because it is brand new. So there's lots of different types of metadata and some projects now that we're in the process of transforming the work into a model where we can load it into the library and publish it out via the API. And so a project like Analysis Result Standards is a good example of that. So a couple takeaways. One, the simplest way for software to get access to standards metadata is via the library API. It's by far the most straightforward way, I would say, to get access to all that content. Second, there's just a lot of new content coming, a lot of new stuff in the library that goes beyond just the foundational standards. Things, again, with the idea that these new projects are delivering metadata that help advance what we can do from an automation perspective. And third, in an increasing number of cases, it's really the only place to find this metadata. We're certainly well beyond what we can effectively publish in a PDF or, say, a spreadsheet. So the library really allows us to include metadata and relationships and things like that would be difficult to do otherwise. So one initiative that hopefully you've heard of that I wanted to call your attention to is the CDISC Open-Source Alliance, or COSA. So this really, again, with our thinking about standards implementation and the need for tooling to really help advance that, we have a directory of open source projects that work with the CDISC standards, and this is growing all the time. We have about 16 listed and more in the pipeline that are coming, including some projects you've likely heard of. We have quarterly webinars where we allow authors to demo and talk about their projects. We've had a number of workshops. We just completed our first hackathon, and that's on Dataset JSON. So there's a lot of activity in the open source space. Dataset JSON is another one I wanted to call out, as it is a data exchange standard for tabular data sets. And so this is something that we've recently put together. It's in draft. And what we wanted to do, in addition to reviewing the standard and get exercising and essentially testing it out, we also wanted to kind of seed the development of lots of different software tools that would do basic things like basically browsing and viewing, but importantly, to convert that dataset JSON into native R data frames, Python pandas data frames, SAS datasets, SAS transport, that kind of thing. And we got over 20 solutions that were created that demonstrated this. And I think that really helps to jumpstart the ability to start to work with a new standard like this. This dataset JSON is part of ODM2, and ODM2 just today has been released for public review. Maybe you got the email for it that gives you information on how to access it. But I think the important thing to think about with ODM2 to understand is that there are a lot of new features that support these new initiatives that we have, these strategic initiatives. One, of course, Dataset JSON is part of that, but generally, ODM is not just XML anymore, it's XML and JSON, so it supports both representations. We will be publishing a reference implementation API after we get through formalizing the standard, publishing it as a final standard. And then there are things like representation of study design models, biomedical concepts. We have support for real-world data, including HL7 FHIR support, enhanced semantics. So a lot of new things and things that we're working on are now supported in this new version of ODM2 that's just entering public review. Okay, jump into another one. So this is another big project we have underway that's called the Core project. It's the CDISC Open Rules Engine is what it's about. And from a CDISC perspective, what we're focusing on really here is creating executable conformance rules for each of our standards. And these rules would be published with the standard. They would be created by the standards development team and tested and basically blessed by that team. So what you get with the standards now would be this set of executable rules. And we're in the process of, we've released a couple of MVPs, but now we're in the process of completing the development of the rules for our existing standards. And then going forward, we'll be authoring rules for each of those standards, again, as they're published. Also important to point out is that, again, as I mentioned earlier, in order to really do something like this, where we have a no-code, low-code metadata representation of a conformance rule, we need some software tooling, one, to help author, and we have a rule editor for that, and then two, to test and execute the rules, and we have our rule engine for that. These are both open source software packages that you can find out on the COSA directory. And these are things, again, as we move the rules and towards completion, we'll continue to evolve these tool sets with the idea that we're working towards a 1.0 release. So additionally, fair to say that there's some vendors that will incorporate the engine into their tooling. For example, if you generate a data set that you want to test for conformance as part of the tool, you could embed core, because it's open source and released under MIT license, you could do that. But we also know there's some vendors that are interested in writing their own engine. And the idea there is that for the rules, if you use core or use a different engine, you should get the same output. So we'll come up with a certification program to make sure that that's a reality, so that, yeah, no matter which engine you use, if you have a rule run against a data set, you should get the same output. So that's a little bit about the core program. Another new one is, which is even newer than core, is Cosmos, which is the conceptual and operational standards metadata services. So probably the part you've heard about the most over the years is this idea of biomedical concepts, and that's a key part of this project. So what biomedical concepts are essentially, they provide the semantics that go with the standards. So it's kind of filling the gap in the standards that we have, and they are created as they're separately, but then linked to the standards in such a way that you can apply them through things like dataset specializations. So we have the concepts as the semantics. We have concept code, they've got definitions, they've got the attributes of what describes a particular concept, and then we've got an implementation of that concept in the different standards. The idea is that concepts exist independently, so you might find it in CDISC, you might find that same concept in SDTM or even ADAM, or maybe in real-world data, if you're using FHIR, the same concept is available there as well. So it exists independently of each of the standards. But we are building what we call dataset specializations, which are essentially, if we take the base standard, it's a configuration of that standard for that concept. So what we see on this slide is, if we, for example, take the vital signs data set, just for kind of a simple example, we have an SDTM implementation guide, vital signs data set definition. And now with the concept, we have, let's say, a concept of height. What that means is you'll have a configured version of this that has the test code, the units, the result data type, the defined data type, the length, all the metadata you need to use to implement it out of the box. So when you retrieve that from the library, you could generate what you need for define XML to include value level metadata. So that's the idea, is that these are configured and ready to use. And then certain bits of metadata, like the defined data type or the length, or things that will come pre-configured, but you can override that if you need to. The idea being, again, it's usable without additional configuration, and then you can tweak it as you go. So this is an SDTM example. You also find we'll do one for CDISC as well. So and there the idea would be you could generate a case report form, and then similarly you could have a associated with the concept a LOINC code for height that would allow you to retrieve it from FHIR. So that's a little bit about the biomedical concepts and dataset specializations. I think the other part that's useful to know about is that we're expanding the metadata that's available, again, for things like you would get in define XML, like the defined data type, the length, significant digits, and so on. But we're also adding the relationships between the variables, which I know is something that's been of interest to many for a long time. So again, there's a lot of additional metadata that will be quite useful for tool builders. This is something that we just stood up recently. We just announced it at our Interchange conference a couple of weeks ago, and there'll be some more information coming around about how to access this through the API and test it out if this is of interest. Another project, it's a big one that we've been working on, is the Transcelerate Digital Data Flow project. So this particular project is led by Transcelerate Biopharma. It's a group of collaborators, so CDISC is involved, along with Accenture and Microsoft. For CDISC, our part of this project is building a reference implementation, or a reference architecture, I should say. And the reference architecture is essentially a technical standard where it includes a study definitions model, the unified study definitions model. So there's a data model, an API specification, and controlled terminology, and then with that, an implementation guides. So that's CDISC's focus on this, is more of a technical standard. Then actually Microsoft is the one building a reference implementation. So there's actually a open source reference implementation that goes along with this. And the idea with this study definitions repository is that we have the details we need in the study definition to drive downstream automation. We worked to complete the first phase of the project, and now we've started on the second phase. And this phase, the use cases that we're targeting are EDC study setup automation, so pushing that further, as well as generating a protocol based on the common protocol template. So that's the project. Again, CDISC's role is really thinking about standards, and in this case, more technical standards, in that we're doing the class diagram, the logical data model, the API spec, then of course, terminology, as well as an implementation guide. In addition, we're working on real-world data projects, and we have sort of a portfolio of projects here. This is such a broad area that, what we've tried to do is focus on targeted projects where we feel like we can really advance our community's ability to bring real-world data into the CDISC standards. And a great example of that is the FHIR to CDISC mapping that we led that project. Then we balloted it both the CDISC and at HL7, so it's a CDISC and HL7 standard. But the idea being that with all the attention placed on FHIR as a great way to grab content from EHRs, to be able to map that into the CDISC standards was something that there was a lot of interest in. So that project is a good example of what we're trying to do. I'll also highlight the fact that another common data model for real-world data, OMOP, is one where there is an SDTM to OMOP, and there's another project that's OMOP to SDTM. These aren't ones we're leading, but just to raise awareness that they're out there. The idea being that we have these, if you think of SDTM, CDISC SDTM as a common data model, we've got FHIR and we've got OMOP, and the idea that we can move data between these models is one that's appealing to many. Additionally, we've got SDTM for observational studies and another project called CDISC Basic. And CDISC Basic, there's a couple of things it's targeting. One is non-regulated studies where essentially folks that are, say, take an academic research center that's doing a non-regulated study, and maybe they're new to CDISC. The idea is that we're focusing on just kind of the most fundamental components of the standard, not as extensive as it might be for regulated research, and targeted documentation, as well as artifacts to help them on their way. So you would have something like REDCap and OpenClinic case report forms that you could use right away as an example. I think the other use case is thinking about real-world data and how some of the challenges with real-world data is it may not be as complete, or it may that the quality might not be quite as high as we would get from data that was generated for research. And the idea there is, can we still create, for example, SDTM that's complete enough to suit needs in that area? And CDISC Basic is an area that we're looking at that. And lastly, I'll highlight our analysis results standards, another one that's generated lots of interest. It consists of essentially analysis results metadata technical specification and an analysis results data structure. The idea being that this additional machine readable metadata then with some software tooling could be used to do things like create TLFs, and we're targeting our common safety displays as kind of our first cut at this. And the idea being that you have Atom, now you've got this analysis results metadata technical spec, and with some tooling should be able to generate results data sets and displays from that. So this is a project that's well underway, and we're working on formalizing the model and how to get it into the library. So with that, that was a quick run through of quite a number of our projects, not all of them. And again, I know that was pretty fast, just a quick introduction to get the landscape of a lot of the initiatives and different collaborations that we have going on. If you're interested in more information, do feel free to reach out or check the website. We're happy to give you some more details.
Thank you so much, Sam, and congratulations again on ODM 2.0.